In this video, we are going to take a look at reflections and symmetry and stretches and shrinking, vertical stretching or shrinking. And so let's talk about reflections. So if we were to reflect it over the x-axis, if we were to reflect one of our base graphs that we talked about in section 2.1 over the x-axis, then the way that that looks as a function is we have y is equal to the negative of f of x. Now remember, your x-axis, that's the horizontal axis. And so when we reflect it over the horizontal axis, that we're reflecting it from top to bottom. And so we have a negative out in front of our function. We're negating our function. If, on the other hand, we want to reflect across the y-axis, remember y is the vertical axis, then this is going to look like y is equal to f of negative x. So we will have that negative on the inside of that function. That will reflect it over the y-axis. It will reflect it left to right and vice versa. So that's top to bottom. That's left to right. Perfect. If we were to look to stretch or shrink a graph, when our value of a is larger than 1, if we were to take a times f of x, then a times f of x, this stretches the graph of f of x by a factor of a. So what's happening there is we're taking every y value and you're multiplying every y value by a. And so if a was 10, you're multiplying every y value by a. It is going to be 10 times as large as it used to be. If, on the other hand, our value of a is between 0 and 1, if we take a times f of x, this will shrink the graph by a factor of a. And so we are multiplying every single value by a, but if a is like 1/2, then every single y value is going to be half the amount that it previously was. So we're going to see both reflections and vertical stretches and shrinks. We will see those in some examples that we look at on our next page. So let's look at some examples. Here we have g of x equals the negative absolute value of x. So again, our parent graph, the absolute value of x, just looks like this. And so that's f of x equals the absolute value of x. So what is g of x equal to? So g of x, it is equal to the negative of f of x. And since it's the negative of f of x, that tells us what? So that negative's out in front of the function. So it's some kind of reflection. So is it reflecting across the xy? So is it reflecting across the x-axis or the y-axis? Because it's out in front of the function, it's reflecting across the y-axis. And so our picture here should look like this. So this green graph, that is f of x equals negative the absolute value of x. And so our range there for that green graph that we've reflected over the y-axis, the x-axis, that looks like has a range of negative infinity up to 0. Great. What about for number 4? So here we have h of x is equal to 1/3 the absolute value of x. So again, our base graph is an absolute value graph. So this is f of x equals the absolute value of x. H of x then is 1/3 of f of x. So is this going to stretch the graph or shrink it? Well, because the number is 1/3, we have a 1/3 out here. Because that value is between 0 and 1, that is going to shrink the graph. And what that means, so this is a vertical shrink. So that means whenever you have a value here, right, so this value was 1, it is going to take that value and multiply that value of 1, and it's going to now be at 1/3. So that value is being compressed. It's being shrunk down to 1/3. When we were at somewhere out here at a value of 2, that's somewhere up here, it is going to be compressed down to 2/3. And all of those values are getting compressed. They are 1/3 the size that they used to be, 1/3 of the height that they used to be. And so this graph, it still looks like a V, it's just been compressed a little bit more. It is flattened, and so we have our picture right there. So we still see the parent graph, we just have a compressed version of that parent graph. All right, in our next video, we will look at taking and putting all of these things together, both the vertical stretches and vertical shrinks, the reflections, and then the shifts left and right. So we will look at some examples in our next video.